Dear students, today we will discuss about some of the fundamentals of AC circuits. I am Professor Vasantacharya and I will be dealing with your subject of elements of electrical and electronics engineering. Now, number one definition is average value. Average value is defined as the arithmetic mean of all the instantaneous value over a specific period. The significance of average value is for rectifier circuits. If we calculate the average value for full cycle, it comes out to be 0 as the positive values nullifies the negative values. Hence, it is calculated for half cycle. The formula for sine wave of the average value is 0.637 multiplied by peak value. Then comes the second definition, that is RMS value. RMS value is the effective value of AC quantity. It is defined as that value of DC which will produce same amount of heat as a AC current will produce when flowing through the same circuit for same time. The most common way to specify AC voltage is 230 volt RMS. It is used for all the power calculations. The formula for sine wave is RMS value is equal to 0.707 multiplied by peak value. For voltage, it will be VRMS is equal to 0.707 into V peak value. Form factor. It is defined as the ratio of RMS value to average value. So, RMS value for AC voltage will be equal to 0.707 multiplied by maximum value and average value will be equal to 0.637 multiplied by maximum value. So, it will come out to be 1.11. So, if we see the significance of form factor, it helps in determining the shape of the waveform, important for comparing waveform and in rectifier inverter design, used in instrument calibration to convert a measured average value to an RMS value. The third definition is of peak factor or crest factor. The definition of peak factor is the ratio of peak value to RMS value, which means peak value divided by RMS value, that means peak divided by RMS, that is 0.707 multiplied by peak value. So, peak value will cancel out in numerator and denominator and the value will come out to be 1.414. Significance of the peak factor, which is also called as crest factor, is that it indicates the maximum voltage current stress relative to the effective value, crucial for determining insulation requirement and the voltage rating of the components. Then comes the definition for real power or active power. Real power or active power, it is that portion of the total power that is actually consumed or converted into useful work such as heat, light or mechanical motion. Whenever we have an electrical device, we will have some output in the form of heat, light or mechanical motion. So, whatever be the output which will be available to us, it is the real power or the active power. It performs the actual intended function of the circuit. It is denoted by capital P and its unit in watts or kilowatts. So, if we check the formula for it, it is VRMS into IRMS into cos phi. It is also defined as the product of voltage and component of current in the direction of voltage. Reactive power or imaginary power. This power is not consumed but is used to establish and maintain the electric and magnetic field in the reactive component like inductor and capacitor. So, reactive power is also important in the circuit, which will determine the power which is consumed in the process or the principle. It oscillates back and forth between the source and the load, representing energy that is continuously stored and returned. The other definition for real power is that it is the product of voltage and component of current perpendicular to voltage. It is denoted by Q and its unit is volt amperes or kilovolt amperes. The mathematical formula is Vrms into Irms into sin phi. Then comes your apparent power. It is the vector sum of real power and reactive power. So real power is P and your reactive power is Q. So it is the vector sum of both the quantities P and Q. This power determines the total current flow and the required capacity for the system components like wire, generator and transformers. Its symbol is S and its unit is volt amperes. So the formula for S is Vrms into Irms. Then comes your power factor. Power factor is a critical measure of electrical system's efficiency. Power factor is defined as the ratio of resistance to impedance of the circuit. It is written as cos phi. Power factor is also defined as the ratio of real power to apparent power of the circuit. A power factor closer to unity means the circuit is more efficient, using most of the apparent power as real power and drawing less reactive current from the source. So the cosine of angle between voltage and current is also power factor, and ratio of resistance to impedance is also power factor, and ratio of real power to apparent power is also power factor. Thank you for watching this video.